This is illustration 90, permutation combination. Now in this question we have to find number of ways of distributing 10 identical balls. So I discuss illustration 88 also, so I prefer that first of all you go through solution of illustration 88 and then come here. So in illustration 88, like it was 5 balls to be divided in 3 boxes, and now this time we have 10 balls, identical balls, to be placed in 3 boxes, right, such that no box should contain more than 4 balls and less than 2 balls. So the constraint is that every box should get at least 2 balls but not more than 4, right. So let x1 be the number of balls placed in box 1, x2 in box 2, x3 in box 3. So x1, x2, x3 represent number of balls placed in box 1, 2, 3 respectively. Box 1, box 2, box 3, and the number of balls represented by x1, x2, x3. So total number of balls placed in 3 boxes is x1 plus x2 plus x3, and that should be equal to 10. And constraint on x1 is it should be minimum 2 and maximum 4. That's mentioned in the question. x1 number of balls to be placed in box 1, minimum should be 2 and maximum should be 4. And same is true for all the 3 variables. x2 also between 2 and 4, and x3 also between 2 and 4. Now so it means number of ways to divide balls to place box in boxes under the constraint is same as number of integral solutions of this equation. Why? Because every solution of this equation means 3 numbers whose sum is 10, and all 3 numbers should be like this. For example, 2 4 4, sum is 10, right, and all 3 conditions satisfied. This is like solution of this integral equation. This is also a way in which balls can be placed in boxes. It means 2 in box 1, 4 in box 2, and 4 in box 3. So it means number of ways to divide is same as solutions of this integral equation. And number of solutions, how to find coefficient of x to the power 10 in the expansion, and how to form the expansion I discussed in 88. For every variable we make a bracket where we place the values that variable can take as powers of x. So for x1 we have this bracket, 2 3 4, 3 values x1 can take, we write them as powers of x and add, right. So in this expansion we have to find coefficient of x to the power 10. So or same as finding coefficient of x to the power 4 in, because see, x to the power 10 we have to find in take x square common, x to the power 6 into 1 plus x square whole cube. We have to find 10 in this, same as finding x to the power 4 in the remaining, right. And that is it is 1 minus x cube over 1 minus x 3, x to the power 4 in 1 minus x cube whole cube into 1 minus x to the power minus 2. And if you apply binomial theorem here, x to the power 4, and we open this, 3c0 minus 3c1x plus 3c2 x to the power 6 goes on cube, sorry. Now if you can see only first 2 terms can produce x to the power 4, not the other terms, right. X to the power 4, when you multiply x to the power 0 with x to the power from this bracket, and x to the power 4, coefficient of x to the power 4 term from this bracket, using the formula n plus r minus 1 cr is coefficient of x to the power r. हमें 4 चाहिए, we want x to the power 4 from here. So n is 3, r is 4, minus 1 c4, minus when you multiply this x cube term with x term, x cube into x is x to the power 4. So the coefficients we have to multiply, minus 3c1 the coefficient of x cube, and x to the power 1 coefficient is n is 3 plus 1 minus 1 c1. So it is 64 minus 3 into 3c1. So you can see number of ways is 64 is 50 minus 3 into 9, 3 into 3, sorry, 9. So answer is 6.